Hi everyone. In this discussion, I will include the physical properties for the acoustic medium in the miscellaneous section, right? So let's rename it with the acoustic medium, right? And let's discuss what is it about. So in STKO, if you are trying to model an acoustic medium, uh, in OpenSees, if you are trying to model an acoustic medium, it is essentially uh, can be a material or a substance that can transmit sound waves. So when simulating acoustic phenomena, whether it is the propagation of sound through air, through water, solids like wood and metal, uh, I think the properties are necessary to define that how the sound behaves with this. So in STKO, especially in engineering mechanics, the acoustic medium refers to the substance or material through which acoustic waves propagate. So let's say you are trying to model a media. Let's say you have this barrier, right? The solid barriers for nuclear testing of, of a bunker or any experimental setup, and you want to check the behavior of this material, and this side is enclosed and this is the solid material, and the purpose is to uh, stop that sound wave here and reduce its impacts here. So in STKO, as I mentioned, the acoustic medium refers to the substance or material through which the acoustic wave propagates. So when modeling acoustic phenomena, it's important to define the properties of the medium accurately to simulate how the sound waves interact with it. So, for example, in an air-filled room, the acoustic medium would be air, while in underwater acoustic simulation, the medium would be water. And for that, if you are working on the materials, you need to define the bulk modulus in your simulation. And bulk modulus, it is important here because it's related to density. And let's say this is minus V. This is the Gorning equation, dP over dt, right? And based on this Gorning equation, this case, the bulk modulus, V is the volume of the material and P is the pressure applied to the material, which pressure will be in terms of the medium we are defining, trying to check it. So the bulk modulus is basically the measure of the given material uniform compression. So it quantifies the pressure required to cause a unit volume change in the material, and this is the material mathematical expression. So here the negative sign indicates that the pressure and volume change are inversely proportional. So if we are using the STKO, we need to define these properties here with how we are trying to achieve our results here. While if we talk about the density, it's quite obvious that it's the measure of mass per unit volume, and rho is equal to from basic engineering mechanics equations. It is something like this, and it's also a material property that we need to input to accurately model the acoustic medium. And the density of the medium affect the speed at which sound waves propagates through it. And with denser material typically transmitting sound waves more slowly less than uh, the material that are not dense. So by specifying the bulk modulus and density of the acoustic medium in STKO simulation, we can accurately model how sound waves propagate to different material and environments. enabling the simulation of various acoustic phenomena with real-world accuracy. So only these two equations are necessary for it. And if we consider the media to be air, then I think the density is 1.2 kg per cubic meter, and the standard atmospheric pressure will be at bulk modulus will be at standard atmospheric pressure is 1.42 multiplied by 10 to the power 5 Newton per meter square. So let's say we have 142 and density is going to be k 1.2. So this is the material property for the acoustic medium, and sometimes it's required in the analysis. Let's see what's the next property. This is bounding clay material, and I think I should cover these videos in the next video, these parameters, because it is a complete different material parameter that is required. Let's see if we get something from OpenSees environment, and the link is okay. All right. So I will discuss this in the next video.